Hi everyone, and welcome to the last segment of ACT Math Prep with Desmos Hacks. If you're just finding this video right now, linked below I have all the other videos that come before this. I have a link to the practice test. I have a video that walks you through how to find this practice test on the TestNav website. I have 5 other videos that have 10 problems each worked out that show you how to use the Desmos graphing calculator to cut down on time. In this video, I will be working through questions 51 through 60, which are theoretically the hardest questions on the ACT. But I think with the help of Desmos that we can cut down time and make these problems easier for you. I hope that this video practice series helps you get the score that you want on your ACT and helps you understand some math better. Question number 51. 12 jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. The 12 jurors will be selected from a jury pool of about 60 people. The court records show a trend that only 40% of the people who are summoned for jury duty actually appear, and that of the people who appear, 1/3 are excused. If this same trend continues, how many people should be summoned to have as close as possible to 60 people in the jury pool? All right, so we have this diagram to help us, and we have some information, but we don't know how many people are summoned. That's our goal. So let's just call the number of summoned people X. Now let's move along with what we know. It says the court records show a trend that only 40% of the people who are summoned actually appear. So summoned appeared. So 40% as a decimal is 0.4. So I'm going to write 0.4 of the people that are summoned. All right, let's look to what else we know. It also says that of the people who appear, so still coming down this line, of the people that appear, 1/3 are excused. So of the people that appear, that's 0.4 of X, 1/3 are excused. So I'm just going to take this and I'm going to multiply that by 1/3 to get the amount of people that are excused. Now, the goal of this problem, which can always be found in the last sentence, it says how many people should be summoned to have as close as possible to 60 people in the jury pool. So we're looking at this part right here. So since this is 1/3 for the excused, we need 2/3 for the jury pool. So I'm going to say 2/3 of the 40% of the people that are summoned. And I want that to be as close to possible as 60. So I'm going to set this equal to 60. Now we're going to go to solve for X. I'm going to use Desmos to do this quickly and efficiently for me. 2/3 times 0.4 X equals 60. And scroll out. I'm seeing my line. Looks like it's right past 200 and less than 300, so it's got to be this D, 225. Question number 52. What is the 275th digit after the decimal point in the repeating decimal 0.6295? So these digits are going to show up over and over and over. And I see that there's 1, 2, 3, 4 of them. And I'm looking for the 275th digit. So I'm going to start with 275 and divide it by the number of digits that repeat, which is 4. When I do that, I get 68.75. So these 4 digits are not going in evenly. To help us out, let's change this 0.75 to a fraction over 4 so I can see which numbered digit it is. So I'm going to change this to 68 3/4. This means that it occurs 68 times, all 4 of these digits, and then I stop at the third one. So 1, 2, 3, I'm looking for 9E. Question number 53. Given that f of x equals x squared minus 4 and g of x equals x plus 3, what are the values for x for which f of g of x equals 0? You ready for one of the best Desmos hacks ever? We're going to come to our Desmos calculator. And we're just going to type all of these things in. So we know that f of x is x squared minus 4. We know that g of x equals x plus 3, and we want to find f of g of x equals 0. These show up as vertical lines. Our solutions are -5 and -1, where our output is equal to 0, so A. I know that this is a composition of functions, but if you're fast at typing stuff in at Desmos, this can save you the time. And this was a number 53, theoretically one of the toughest problems that the ACT has to offer. And you can just type it into your graphing calculator. How awesome is that? Question number 54. Given that p is a positive number and n is a negative number, and the absolute value of p is greater than the absolute value of n, which of the following expressions has the greatest value? For these, what I like to do is I like to plug in numbers for these. We know that p is a positive number and n is a negative number. And then when you take their positive versions, that p has to be greater. So I'm going to let p equal 3 and n equal -2. And we can see this here real quick. The absolute value of 3 is 3, and the absolute value of -2 is 2. So this checks out. So this is where I'm just going to let Desmos do its magic again. I'm plugging in 3 for p, -2 for n, and then seeing which one of these wins out. Let's get that graphing calculator up. Okay, so here's what I'm going to do. I'm going to type in A. We need absolute value, so I'm going to do shift key underneath the backspace, and then I'm just going to type in what I see. So p minus n over p, and then close out that absolute value bar. And I'm going to come down here and I'm going to say that my p-value is equal to 3 and n is equal to -2. And it's just going to compute the answer for me, and I'm going to see which one is higher. So we got 1.67. Now let's check out B. Let's do p minus n over n. I have 2.5. B's winning so far. C, p plus n over p minus n, 0.2. That one's losing. B's still the winner. D is p plus n over just the p, 0.3333. B's still winning. Our last one to check, p plus n over n, 0.5. So it looks like B wins out here. Question number 55. If I equals the square root of -1, then I plus I squared plus I cubed over I cubed plus I to the 4th plus I to the 5th equals what? This problem can be done by factoring. What I'm going to do is I'm going to factor out an I out of the top because all 3 of these terms have an I in them. So I have I. What I have left then is 1 plus I squared. And then on the bottom, the greatest common factor of these 3 terms is I cubed. And then I'm left with 1 plus I squared. And if I multiply these back out by distributing, I'll see I get this. And then if I multiply this by this, and this by this, and this by this, I'll see I get the bottom. What's so fun about doing this with factoring is when you change it into a multiplication problem, you can make what I like to call a really fancy one. These things are the same, so this makes a fancy one. Now what we need to do is we need to use some properties of exponents. If I have 1 I on top and 3 i's on the bottom, again, I have a multiplication problem. I can make a 1 through these. So I have 1 over I times I, which is I squared. If I square this I and I square this I get that I squared is -1. And so I'm just going to plug a -1 in here in the bottom, 1 over -1. And 1 divided by -1 is B, -1. Question number 56. In one of the following graphs in the standard XY coordinate plane, the solution set to the system of inequalities below is shown shaded. Which one? So I have this, and what I'm going to do here is, again, go to Desmos graphing calculator, type in these 2 inequalities, and see which one of these 5 match. Okay. Our first line says x plus 2y is less than or equal to 6. And our second line says 3x squared is greater than 12 minus 3y squared. The solution set for this is going to be where both of the colors overlap. So we have a blue color and a red color here, and we can see that that overlap is happening right out here. So we just need to find out which one that is. We also can see that that line is going down from left to right, and it's on top of the circle. So no, 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 yes, E. Question number 57. Let A, B, C, and D be real numbers. Given that AC equals 1, B plus C over D is undefined, and ABC equals D, which of the following must be true? What I'm going to do here is I'm just going to start with A and go all the way down until I get a right answer to see which one of these must be true. Okay, so the first one says A is 0 and C is 0. Let's look at this. A is 0, C is 0, and that is equal to 1. And we're asking which of the following must be true. Well, 0 times 0 is not 1, so A doesn't work. Let's move on to part B. A is 1 and C is 1. Let's come here again. 1 times 1 equals 1. Now, that might be true, but it says that it must be true. Do we know for sure that A and C are both 1? Well, what if A is 2 and C is a half? That equals 1. And what if A is 3 and C is a third? That's 1. So must it be true? Not necessarily. So B doesn't work. C says A equals negative C. Now I had a couple examples up here. So we had 1 times 1 equals 1. And we can see here that if we divide by the C value or 1, that doesn't become a negative C. We also had 1 times 1/2 equals 1. And again, that doesn't get us out with a negative number. So we're going to say that this doesn't work because we're not getting negative numbers with a couple examples that we just showed. And we're looking for something that must be true. D says B equals 0. I'm going to jump to this one for this. If A and C have to multiply to be 1, they cannot be 0 because anything multiplied by 0 is 0. So if B is 0, this whole thing becomes 0. So that is the thing that must be true. This one is answer D. Question number 58. A cosine function is shown in the standard xy coordinate plane below. One of the following equations represents this function. Which one? So we don't need to know anything about trigonometric functions as long as we know how to change our domain on Desmos, and I'm going to show you how to do that. So let's come to the graphing calculator. Okay, so here's what I'm going to do. I'm going to come up to the wrench, and I want to change my x-axis to going to a step of pi over 2. And I'm picking pi over 2 because this says pi over 2, and I can just type pi, I can spell it out, pi division bar 2, pi over 2. I also want to be in radians because when I see pi's along the x-axis, instead of in degrees, I am in radians. So let's flip this over to radians real quick. And as long as we know this, we can just type these in to see which ones match. And if I want to see that pi over 2, I can just zoom in a little bit. Okay, so doing just a little bit of zooming in out, now I'm able to see that pi over 2. And we can also see these y heights of 1, 2, and 3 because we want this to come up 1, 2, 3. So let's just go through our options. Y equals 2 cosine of x over 3. Looks like it's reaching a height of 2. I need it to be a 3. So I don't want to use 2s. Let's go and maybe use these right here. So let's change this to a 3, see if it matches. So now I have a height of 3. I need it crossing before pi over 2. So it can't be C. Let's go x over 2. Not working. Let's change it to 2x. Looks like that's it, right? Reaching that height of 3, coming down to 3 as well. I'll zoom out just a little bit. Okay, so you can see that 1, 2, 3. Come back in and zoom in. And we can see that it's crossing the x-axis and coming down right before the pi over 2. So it looks like this is option E. Question number 59. The figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation at 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 240 feet from A on level ground, is 45 degrees. What is the length in feet of the string? So this right here, I'm going to call X is our goal. This is a perfect problem to use the law of cosines, which is the sine of some angle A over its corresponding side A is equivalent to the sine of some angle B over its corresponding side B. And I'm going to show you how to set this up. So the first thing we need to do, because we're given this side and we're going to need to use this because I need information about two sides, is I'm going to use the triangle angle sum theorem to get this angle. I do that by taking 180 minus 75 minus 45. And that's equal to 60. So I'm going to put this right here. And now what I'm going to do is I'm going to plug things into this formula. So I'm going to do the sine of some angle A and its corresponding side. I need to use this piece because this is the only side I know. So I have sine of 60 over 240 equals, now I need to get this side length, so across from that is 45 degrees. So I need the sine of 45 degrees over X. I can just plug this into Desmos now. I want to preference, so in a previous problem, I changed all of this to be pi's over 2s and changed it to radians. So if you're working in degrees, you need to make sure that you change this stuff in here to degrees, okay? We don't need to change your step if you want it out of there. Backspace it, but we are using the calculator here, so all we need to do is make sure that this is in degrees. We're talking about angles, and radians and degrees talk about angles. That's the only time it matters. So what I'm going to do is I'm just going to plug this in because I want Desmos to solve it for me. So I'm going to write the sine of 60 over 240 equals the sine of 45 over X. Okay, and I'm going to scroll out and try to find this. Okay, here she is. I'm going to zoom in close. So I need a number that is looking like it's maybe about 196 or close to it, okay? So C, D, and E do not look like they are 196. So I can just check to see which one of these matches. 60 times the square root, sqrt, of 3. That's 103, doesn't work. I can automatically say B, but let's just show it. 80 sqrt for square root 6 is, and that was that number that was really close to 196. So this option is B. Question number 60, the last question. If a publisher charges $15 for the first copy of a book that is ordered and $12 for each additional copy, which of the following expressions represents the cost of Y books? Now, don't be fooled here. It's very easy to think of your prior knowledge with Y equals mx plus b and say that, well, it's $12 for each additional copy, and we don't necessarily need this Y equals stuff because it's an expression, okay? So it's not even technically an equation, but you could say 12x plus it started with 15. And keep in mind, they're using Y for this variable as well. So let's just maybe just change this to Y so we don't get confused. Okay? They want you to fall into this trap. This is 60. So if you're thinking that, wow, I got this too fast, you did. Because the key thing here is that the first copy of the book is $15. And so this assumes that 15 is 0. You need to subtract 12 from this 15 to get the price of the 0 book, if you will, okay? So 15 minus 12 is 3. Now we'll see if I plug in a 1 for the first book, 12 times 1 is 12 plus 3, I get my first book is $15. If I did that here, 12 times 1 plus 15, well, that's 12 plus 15, and my first book is not 27, okay? So don't let them trick you on the last one. Just read the question really closely. So this was option A. You did it. You made it through 60 questions of practice. You should be so proud of yourself. This compliment is not given lightly. You put in the work, and I'm sure the work that you're doing and the practice that you're doing are going to help you do better on this test. It's also going to help you be a better math student. So if anybody's ever told you that you aren't a good math student or you can't do good on this test, tell them that they're wrong. You can do this, and you can be a math student. If you liked all this work with ACT practice, make sure to check out my YouTube page, Math with Mel. On there, I have other math practice. I also have some fun Desmos art. Like this video and make sure to subscribe.